2 students. You have finally made it, so congratulations. This is the last day of word problems for Chapter 2, and we will once again look at 2 problems in your notes and then start working on your homework. Now, I want you to understand that I don't know if every chapter for the rest of the year will have 3 parts to the word problems. Some chapters might have 4 parts, some might have 2 parts, 1 part, okay? So it's just kind of a coincidence. The first 2 chapters have had part 1, part 2, and part 3. I'm not going to say that every chapter for the entire year is going to be that way, okay? Alright, your heading for today is Chapter 2 Word Problems Part 3. So please copy that down, and as I say to you every single day, I would always put the date in your notes so you know what the heading is, and the lesson number, if there is a lesson number, and the date, okay? So please copy all of this down. Please take really good notes. As I'm working these problems out, please remember, do not ask yourself, would I have ever thought to do it that way? Or, man, there's no way I would have thought to have done it that way. Instead, ask yourself or say to yourself, do I understand what he is doing? And I think most of the time you're going to say, yeah, I would not have thought to have done that, but now that he's explained why he's doing it, I understand it. And here's why I tell you this. I tell you this because if you understand what I'm saying, eventually you will think to do, eventually you will think to do a lot of the things that I do with practice, okay? So the more practice you have, the more you're going to get used to doing word problems like these. I want to talk to you for a second about why I give you homework word problems. I might not put all of these on your tests and quizzes, but understand something very, very carefully. There are 2 types of students. Those that get homework just to GED, get her done. And then there are the types of students who do homework in order to learn. Now, I have 5 children. I can tell you right now which one of my 5 fall into this category and which ones of my 5 do not, okay? You're going to have to make that decision. You're going to get a lot of your education from the homework with word problems and from the homework that's not word problems. That's why I feel like you should do every homework problem on every assignment and check your answers in the back of the book or check your answers with the homework help video. I'm just telling you guys, part of your education is not just me teaching you, it's the homework where curveballs are thrown at you and you watch how I work those problems out, okay? Alright, let's jump into this. 2 word problems. In your notes I would write page 103 and that would put example 3. So in your notes write page 103, example number 3. Let's do part A first. It is raining at a steady rate of 0.5 inches per 2 hours. Excuse me, that's incorrect, sorry. It's raining at a rate of 0.5 inches per hour. That means every hour a half an inch of rain falls. Another hour, another half an inch. Another hour, another half an inch. Now this does this for 2 hours. What is the total rainfall, excuse me. Well guys, this might be the easiest problem we've done in Algebra 2 all year. If it's raining a half an inch every hour, and we do that for 2 hours, then obviously we take 2 times 0.5, and you're going to get 1 inch. That was pretty simple, okay? Alright, now, part B's where it gets difficult. Part B says now, a rainfall lasts for 2 hours, okay? A rainfall lasts for 2 hours, but it's not a steady rainfall. It starts off with a drizzle, and then it builds up from the drizzle to a heavy rain, and then it drops back down to a drizzle. So if you were to graph it, it would look something like this. It starts off it is. In fact, since it looks like a V-shaped graph, you could probably model that using what type of model? Remember how we've graphed absolute value functions, and when we graphed them, they looked like V's. And look at this. They're telling you you can model it by this absolute value graph right there. Very interesting. So let's continue on and let's see what we get. Let's see what we get here. Okay. We have a rainfall. It starts off with a drizzle, builds up to a heavy rain, and then backs back down to a drizzle. The rate R of rain in inches per hour is given by this model here, where T is time in hours. So for 2 hours, we have it. We have the rain. It starts off raining slowly, then increases to a heavy downpour, and then tapers back down to a drizzle. This model here does a couple things. You can put in a time in hours. You could put a 1 in for 1 hour, or a 1.5 for an hour and a half, or you could put in 1.7 for 1 and 7/10 of an hour, and it would give you out the rate of the rain in inches per hour at that time. Do you see what I'm saying? The rate of the rain is given by this right here. So you can put in a time and get out how hard the rain is falling. And of course your time is in hours. So their question is what is the total rainfall? Now, this is really, really, really tricky because my goodness, you could put in 0.1 and get out how much rain fell. And then put in 0.2, then 0.3, then 0.4, all the way up to 1, then 1.1, and get all these rainfalls up and add them all up. That's one way to do it, and that would be pretty difficult to do and very time consuming. Okay, in fact, it really wouldn't be that accurate because then what about 0.01 of 1 hour and 0.02? So the best way that we can find the area, the total rainfall is to look at a graph. Okay, now please just sit back and watch and listen to me. You know how to graph. Please listen to me. Don't freak out here. We can do this. We know how to graph absolute value functions. We really do. First we find the vertex. So we take the inside of the absolute value. We set it equal to 0. And we solve and we get t equals 1. So I have a 1. Then, so my x value here is going to be a t, and my y value is going to be an r. Now remember, whatever number is being added or subtracted is your y value or your r value. I'm going to use a fraction instead of 0.5. So there, just like that, I've got my vertex. Now, you're used to doing this. Remember, you're used to putting a table of values with 5 ordered pairs. Don't do that. You're used to doing that, putting the vertex right here. Mr. Earhart, you're the one that taught us to do that. You're correct, I did, when you're graphing functions. But in this case, in this case, listen to me, we're graphing a function in the context of a word problem. You know what? It would be identical to reading a Bible verse without reading it in the context of the verses around it. You can't do that. Okay? Same thing here. If I just give you a function and tell you to graph it, fine. Find the vertex, fill in your 5 ordered pairs, and graph your v. No problem. But this is in the context of a word problem. So we're going to do it a little differently. This will make sense. Well, first of all, I shouldn't put an x and a y. I should put a t and a r. Secondly, I'm going to put my vertex right in the middle with 3 ordered pairs. Now, why am I doing that? Here's why. I want to find out what the rain was doing at 0. And I want to find out what the rain was doing at 2. Now, we should know when 0 time has passed how much rain has fallen. 0, that's pretty obvious. Now, if you want to substitute 0 in, feel free to do that, okay? No problem. Go ahead and put a 0 in right here to this function, and you'll get out 0. Okay, watch. Put a 0 right here. 0 minus 1 is negative 1 with a negative 0.5 here. The absolute value of negative 1 is positive 1. Now multiply these. Negative 0.5 times a positive 1 is a negative 0.5. Then bring down your positive 0.5 and they cancel out and give you 0. Okay? Now, let's see what happens when I substitute 2 absolute value of 1 is 1 times negative 0.5 is negative 0.5. Bring down your positive 0.5 and you get out 0. So why did you set your table of values up like this, Mr. Earhart? Because I have a word problem. And since I have a word problem, I have to graph my function in the context of my given domain. T has to stay between 0 and 2. So now I've got a pretty good picture of the graph here. Now in your notes, I would encourage you to sketch a graph. I'm going to be a little lazy and use the book's graph. And by the way, if you're in your book on page 103, instead of copying a graph down, you might want to make a note in your notes. Something like graph is in book on page 103. That's fine. But there it is, right there. See this ordered pair 0, 0. There it is right there. See this vertex 1, 1/2. Look, over 1, up 0.5. So there's the vertex. See this ordered pair 2, 0. Here it is. Over. This is a half. 1, 1.5, 2. Over 2, up and down 0. So there's my graph right there. As I like to say, booyah. Alright, we're done. So there's my graph. Now, the question is, it's kind of funny, we still haven't answered the question, but we're building up to it. What is the total rainfall? So, think about it. At a half an hour, the rain that's coming down at that point is about 0.25 inches. And at this time here, at 15 minutes of an hour, is about one-tenth of an inch is falling at that second. And then here, at this point, the total rain is about 0.05 of. Anyways, what I'm trying to show you is this: as you work your way up this line, you're getting different amounts of rain. So I could keep putting little lines here and finding how much rain has fallen. Or what I can realize is, here it is. Hopefully this is going to be an aha moment for you. What you're really doing is you're finding the area of the triangle. Now I know it's hard to understand, and some of you will just have to do it and say, okay, I don't quite understand it, but on these types of problems, I'll have to learn to use the area of a triangle. But let me show you again why we're doing this. Think about it, guys. Every time, look, the number right here is 0.25. Well, that means the area of this line here is 0.25 from here to here. Okay, that's the height of that line. So if I kept doing that with lines over and over and over, and put the lines so they're right next to each other touching, then you basically come up with the area of this triangle. So if I want to find the total rainfall, I do it by finding the area of this triangle. Now, how do you find the area of a triangle? I'm so glad you asked that question. Thank you. We should remember this from geometry and from other classes. Area of a triangle equals 1/2 times the base times the height. Now, the base of the triangle is 2 because it starts here at 0 and goes all the way over to 2. So the entire base has a length of 2. What about the height? Well, the height of the triangle is right here in the middle. And so we know we went over 1 and up how far? A half. This point right here is even with 0.5. So I went over 1, up a half. So my height is a half. And by the way, the vertex, if you look at your notes, the vertex was 1, 1/2, which means I went over 1, up a half. So the height is a half. So if I take 1/2 times 1/2 times 2, I'm going to get 0.5 or 1/2. So the total rainfall was a half an inch. That's the total rainfall. Okay. Alright, there we go. Moving on to the next problem. This is tough to see, I know that, guys, okay? But if you use the thought process I've given you, you'll be fine. Okay, last problem, we're done. Now this one here, I'm going to go really fast because we just do not need to spend a lot of time on these, okay? The data in the table shows the age in years and the number of hours slept in a day by 28 infants who are less than 1 year old. Okay, so it's showing as they get older, their sleep becomes less. Okay, we know that babies sleep a lot when they're little infants, newborn, and they sleep less as they get older. My teenagers sleep like 1 hour per night, and they're up bouncing off the walls. So with this in mind, what they want us to do is they want us to write a linear equation that fits this model. Now they've given us here 2 points to use. I don't like these points because of the decimals, but we're going to use those. So we're going to write a linear equation that models this scatter plot by using these 2 points here. So here we go. I'm going to write them here and then cut and paste them. So 0.05, comma 15.8. Get out your calculators, guys. We're going to need them with all these decimals. 0.8, comma 13.4. There we go. So we are now ready to write our linear equation. Using these two ordered pairs. So whenever you have two ordered pairs, here's the model that you use. You should know this. Y minus y subscript 1 equals mx minus x subscript 1. The first thing we must do is find the slope. So we have y minus y, 15.8 minus 13.4 over x minus x, 0.05 minus 0.8. Grabbing my calculator, I would have, I believe, 2.4 for my numerator, 15.8 minus 13.4, and then 0.05 minus 0.8 would give me a negative 0.75. Now, by the way, notice your slope is going to be negative. A positive divided by a negative is a negative. And does that make sense? Look back at the line. It's not your line. Here's the left side. Here's the right side. Is your line not sloping down? Does it not have a negative correlation? Sure it does. So it makes sense your slope is negative. Now, 2.4 divided by 0.75 gives me 3.2. So there's my slope, negative 3.2. Alright, so done, moving on. Now, which ordered pair are you going to use? I don't really care. I happen to like this one a little more, so I'm going to use this one. Y minus your y, 13.4, equals your slope, negative 3.2, and then your x minus your x, 0.8. Here we go. Y negative 13.4 equals negative 3.2 times x. Negative 3.2x. Negative times a negative is positive. Don't forget to watch your signs. 3.2 times 0.8 is 2.56. And now we're going to add 13.4 to both sides. Bring it over and make it positive. So y equals negative 3.2x plus 15.96. Now I guess I should look in the book and make sure I've not made any mistakes on this problem, but it's pretty much been cut and dried, and the only thing I did wrong, and I apologize, I'm not setting a good example, I told you guys yesterday, I believe it was, is that you must put the right letters in for your variables, and I apologize for making that mistake. In the problem it says we have T in years, and H is the hours slept. See, this axis right here is labeled H, so H goes in place of your Y. See how this T right here is on this axis, so T goes in place of your X. So for my X right here, I really should have had a T, so using your eraser, put a T right there. And for my Y right here, I really should have put an H. And now we have the correct answer, okay? So guys, that's it for today. The main, only on your homework, I give you one of these problems here. Okay, they're just easy. There's no need to give you more than one. Find 2 points, write your linear equation. On these types here, I've given you quite a bit, and you're going to find these pretty challenging, which will be good for you, okay? Alright, I hope this video has been a help to you. If you have any questions, never hesitate to call or email.